This video will discuss linear programming. Now, linear programming is a process we use to find a minimum or maximum value uh, of some specific linear function that's based on constraints that were provided. Now, these constraints often are forms of inequalities, and they're going to create some bounded region that'll look something like a polygon. And within that, we're going to use the vertices of that bounded region to help determine what's the maximum value. Now, any value inside that region will satisfy the function, but if we want to maximize it or minimize it, that's when we want to use those vertices. We often use this in economic situations, and it can be used with things other than linear functions. However, that's what we will stick to for these examples. So if we want to solve a linear programming problem, the first thing is to determine what are the variables. Then we want to construct the inequalities that relate to each of the variables for each of the different constraint situations. We're going to graph them and then determine where are all the vertices. And once we have the vertices labeled, we know the points at which we're going to try to plug into our maximum or minimum function. Next, we have to determine, well, what is that specific function so that we can plug those points in. Once we know the function, we're going to substitute in our values and see which of those specific values gives us our maximum or minimum and what specific that value would be. So let's look at this example. Say that a company has a narrow-body jet and it can hold up to 320 passengers. And they want to try a new pricing scheme, so they're going to create two tiers. Tier 1 is getting their tickets 3 months in advance or more, and Tier 2 buys them with less than 3 months. So they sell those Tier 1 tickets at $180, the Tier 2 tickets at $220, and they need to have at least 75 Tier 1 tickets sold, but they don't want to sell more than 150, and they need to sell at least 200 tickets total for them to maintain a flight. So you want to know what's the way we can maximize our profit. How many of each of these tickets would we want to try to sell? So the first thing we want to start with are our variables. And the two variables we have here are Tier 1 and Tier 2 tickets. Now it doesn't matter whether I choose which one to be X and which one to Y. I just chose them in this order. The next thing I want to look at are my constraints. So I'm going to start going through what are the constraints I have. I know that my Tier 1 tickets have to be at least 75, so greater than 75 tickets, but less than or equal to 150 tickets. So there's my first thing. Here's my two constraints. My next constraint is I need to sell at least 200 tickets. And technically, the most tickets I can sell are 320, since there's 320 seats. So I know that when I add my two tickets together, they have to be greater than or equal to 200, but less than or equal to 320. So I have my four constraints. And now I can plug that into a graph and see what I end up with. And here are my graphs. Now if you see, the shading is, you get quite a bit of shading, but you got to pay attention to what's the bounded region. And in this case, the bounded region is this parallelogram right in the dead center. So any of these values inside the parallelogram will be true and accurate for solving these constraints, but we want to maximize the profit. So we're only going to look at the four vertices, and those are marked on this picture so it's easy to see. And I used a program called Desmos, and when you go to Desmos you enter in each of these constraints, and then you can click on the corners and you'll see those values pop up. Now the thing is, what is the profit I'm trying to make? And my profit is based on how many tickets I sell of Tier 1 at $180 plus how many tickets I sell at Tier 2 at $220. So if I do 180 times X plus 220 times Y, that will tell me how much profit I'm going to make in this case. So I take each of these four vertices and I plug them into this profit function. And I can see here, again, I use Desmos to do this. I plug in the values, each of those 75 and 245, 150 and 170, 75 and 125, and 150 and 50. And you can see I'm looking at which one causes the greatest value, and it's the first one where I have 75 tickets at the Tier 1 and the rest are sold at Tier 2 because they do want to make the most money. So the best way they can make their money is if they sell only exactly 75 at the Tier 1 level and then 245 tickets at the Tier 2 level, that would get them all the way up to 320 tickets, and they'd have a profit of $67,400.